Hello Legacy students, Marsh here. So today we're going to write equations of parabolas. You're going to want your notes on you, a pen or a pencil, and then also a calculator just to see where I'm getting some of these numbers. Learning target for today, you can write the equation of a parabola when given key information. So, general form of a parabola. The two forms we're going to be using to start with. We're going to use vertex form and intercept form. It's kind of hard to start in standard form and build from there. So we'll be using vertex and intercept form primarily to write the equations of parabolas. Steps to writing them. Depending on what kind of information you're given about the parabola, you're going to decide which form to use. If I'm given the vertex and a random point, I would use vertex form, right? Because there is the vertex in that equation. If I'm given the two x-intercepts, then I would use my intercept form. So being aware of what am I given, so that way you know which form to plug into. You're going to substitute the key information, and then you're going to substitute the x and y from the point that crosses through. We're going to solve for a, and then we're going to rewrite the equation. So normally you are never given the a term. You're never given the stretch of your graph. That is what the random point's going to be for. Let's take a look at a couple of examples. So I got example 1 here. So I'm going to write the equation of the parabola that has a vertex of -3, 2 and passes through the point of 4, 5. Well, since I'm given the vertex, I am going to need to use vertex form. So this guy right here. I'm given the vertex, so I'm going to plug that into my h and my k. So I went left 3, so that would be x plus 3 squared, and then I went up 2, so that would be a plus 2. Notice, guys, you do not know a, but you are given this random point of 4, 5. Well, this is just your x and your y. If I plug those in, I only have a left in your equation, aka I can solve for a, because you can't solve when you have multiple variables in your equation. So let's plug in our 5 and our 4. So I'm going to get 5 equals a 4 plus 3 squared plus 2. Now, got to do some math here. So I got 4 plus 3, that's 7. So that'll be 7 squared. That would be 49. So I got 5 equals 49a plus 2 right now. Now, got to solve for a, get him alone. So I'm going to subtract 2. I'm going to move up here. 3 equals 49a. Woof! Divide by 49. So 3 over 49 equals a. And to my knowledge, 3 over 49, I believe that is as simple as he can be. Yeah, that is as simple. So this is my a value. Really gross, but nevertheless, it's the a value. So now what we're going to do is we're going to take this a value and bloop it right back into our equation so we can have our final answer. So my final answer, f of x equals 3 over 49 x plus 3 squared plus 2. That will be the equation of my parabola. Now, could you get this into standard form as well? Yes. What I would have to do is expand this middle term and rewrite it, but since it does not require us to go into standard form, we're going to leave it in that form. It's going to be a lot easier. Now let's try the second example. So I got an equation of a parabola that has x-intercepts of -1 and 6, and it passes through the point of 1, 5. So notice how this is different than the first example. I'm not given the vertex on this one. I'm given the x-intercepts, but I'm still given that random point. But since I'm only given the x-intercepts, I need to use intercept form. So I got y equals a, x minus q, x minus r. Got to use my intercept form on this particular one. So let's plug in our intercepts into my q and my r. X plus 1, because it's a negative. Ultimately, I'm thinking, what equation would solve to give me -1? And then what equation would solve to give me a +6? Now, we have this random point. That's for our x and our y, because I know what's on the parabola. So since it's on the parabola, I can plug that in to find our a value. So let's plug in our 5. We got a 1 plus 1, 1 minus 6. I'm going to figure out what each of these are. So 5 equals a times 1 plus 1, that's 2. 1 minus 6, that's -5. So I got technically 5 equals -10a, right? Because these are multiplied. So I'm going to divide by -10. So I got 5 over -10, which is -1/2. And that's a. So let's plug that back into this equation right here. So f of x, which is just a fancy form of y, remember, -1/2 x plus 1 x minus 6. Awesome! Let's try the last example here. So I got the equation of a parabola that has the x-intercepts of -9 plus or minus I square root of 5, and it passes through the point of 7, 9. Now, we've looked at parabolas that have this. That means that they do not have real intercepts. They don't cross through the x-axis. So, how do we deal with this? We're still going to use vertex form. So we're still going to use this equation, or not vertex, intercept form. Can't get myself straight here. So we're going to use the intercept form here because we're given their x-intercepts. Now you're probably saying, how am I going to plug that in? Well, technically this is 2 x-intercepts, right? We got -9 plus I square root of 5 and -9 minus I square root of 5. Those are your 2 x-intercepts. So here's how we're going to actually plug that in. We're going to go x minus, parenthesis, -9 plus I square root of 5, and x minus, parenthesis, -9 minus I square root of 5, parenthesis, parenthesis. Whew, gross, gross, gross. So, what are we going to need to do here? Can't really leave it like this because those I's, and never really want to leave it like that. So we're going to actually have to do some foiling and some multiplying out. So, I'm going to first distribute these negatives that I got in here. So I got a, he's just going to kind of stay right there. X plus 9 minus I square root of 5. If I distribute that negative in, distribute the negative here, x plus 9 minus, plus I square root of 5. Okay, let's multiply all this business in, shall we? Let's FOIL these two. It's actually going to be a lot longer foiling because it's trinomial times trinomial. But x times x, I'm just going to kind of forget about a for a little bit. He's going to be sitting out there for a while. X times x, that's x squared. X times 9, that's 9x. X times I square root of 5, that would be like ix square root of 5, something like that. Let's multiply the 9 in now. 9 times x, 9x. 9 times 9, 81. 9 times I square root of 5, that's 9I square root of 5. Multiply the negative I square root of 5 in, so that's negative ix square root of 5. Minus 9I square root of 5. Almost running out of room here. And then, ooh, negative I square root of 5 times I square root of 5. That would be negative I squared square root of 25, right? Multiply the outsides, multiply the insides. Okay? Oh, please tell me stuff cancels. Oh, ix square root of 5 and a negative ix square root of 5. That looks good. And then 9I square root of 5 and minus 9I square root of 5. Yes! Cancels off. I squared square root of 25. That simplifies down. Let's do a little side note here. So I got negative I squared Well, that's not a very good side note area, is it? Let's side note over here. Negative I squared 25. I squared, guys, remember that's negative 1. So if I had a negative I squared, so technically that's a positive 1, square root of 25, which is just 5, right? So this right here, this little piece right here, that's technically just a positive 5. So let's combine what we know. We got x squared plus 9x plus 9x. So we got y equals, we still have that a sitting out there. X squared plus 18x plus 86. There we go. And we're not fully done yet. Gotta plug in our 7, 9 so we can find our a. So I got 9 equals a. 7 squared plus 18 times 7 plus 86. 86. So I'm going to get 7 squared. I'm going to figure out what that is on the inside there. So 7 squared, that's 49, plus 18 times 7, plus 86, 261. So I got 9 equals a times 261. Let's divide by 261 here. Let's see if that simplifies down. 9 over 261. Looks like a 9 can go into both of them. So if I divide them both by 9, I'll get a equals 1 over 261 divided by 9. That's 29. So a is 1 over 29. So I'm going to take that and pop that right in there. So my final answer is f of x equals, and I'm going to distribute that 1/29th in, I think, as well. So 1/29 x squared, then 18 over 29 x plus, and then 86 times 1 over 29, which is 86 over 29. That would be my final answer to this particular problem. Gets kind of messy when you have i's. However, the I should always cancel off when you're multiplying it out. So this one, when you have imaginary x-intercepts or imaginary roots, you want to get into standard form so that way it looks cleaner. Are you always going to get really gross fractions? Not necessarily. Sometimes you'll get really nice, like a half or 2 or something like that. It all depends. This one in this case gave me really gross fractions. And that's the end of this video. See you later, Sabers.